In this video, we're going to start our discussion on conic sections, starting with the parabola. Conic sections, or conics for short, get their name because they are two cones, hence conics, that you put tip to tip, and if you slice them at certain angles, the resulting shapes or curves are what we call the conic sections. So there are four types. There's a parabola, a circle, an ellipse, and a hyperbola. So we're going to talk about the parabola today. And if you slice it at this angle, you're going to get this kind of curve here, which we know can be expressed in the form of a quadratic equation. So every parabola, no matter how it opens, whether it's up or down or to the right or to the left, no matter where it is on the XY axis, it has the same five components: a vertex, a focus, an axis of symmetry, a directrix, and something called the lattice rectum. So the first thing that I always look at is the vertex. That is, in this case, our minimum value, but if it turns the other way, it would be the maximum value. And if it opens to the right or to the left, it's not quite min or max, but it is the most quote-unquote bottom point, and we represent it with h comma k. Sometimes it's centered here at the origin. Most of the time it's not centered at the origin. So equidistant from the vertex is a focus point and this line called the directrix. So they're parallel to each other, and this axis of symmetry runs perpendicular to both of these. So the focus is always on the inside of the curve or the arch, whatever you want to call that. So if you have those 2 points, you can actually figure out the direction in which it's going to open. So something else is that there are these two points that lie right across from the focus, and the distance is what we call the lattice rectum. So, and that's represented by something that we define as 4a, and we'll take a look at a in our equations in just a moment, but it's always 4a for the parabola, which actually helps us if we have these 2 points, and I know it's going to create a curve like this. If I have the distance, I can cut it in half, find that point, and find that point. And of course, the information doesn't stop there. So the thing to know about the vertex of a parabola is that it could sit on the origin or not. So let's take a look at the 4 cases where it sits on the origin, or 0, 0, which means that my h is 0 and my k is 0, which makes the equation real nice because I'm working with 2 zeros there. So what I was talking about before, where things open to the right here or open to the left, those two things start with y squared, and that's going to give you either negative or positive 4 times a times your x value. So the axis of symmetry is going to be the x-axis, which is right here. It's going to run straight through the vertex and the focus, and it's either going to open to the right or to the left, depending on if it's positive or negative. So on the opposite side of that, instead of starting with y squared, you start with x squared, and that's when your parabola opens up or opens down, which is a lot closer to what we know of our classic parabolas, whether they open up or down. What's probably new to you is the right and the left, but really you just switch the x squared and the y squared, and that's how that works. So if it starts with the x squared, opens up or opens down, it's going to have the axis of symmetry is the y-axis. It's going to go straight through that vertex and that focus, and like I said, it's going to open up or open down. And you can check out this chart in your book, or you can copy it straight from here. So what happens when the vertex is not at the origin, you ask? Well, we have to use our h and k values. So remember, the vertex is h comma k. We have to use those values and plug them in next to our x and our y, depending on how that parabola is going to behave. So the parabolas aren't any different. They've just moved around, much like when we learned about the equation of a circle. So when the equation of a circle is centered around the origin, you don't have to worry about anything else. But when it moves, you need that center, that h comma k. Same kind of deal here. Notice that a circle is also a conic section, but I digress. So let's take a look at 2 parabolas that open up and open down. Notice that all I do here is subtract my h, subtract my k, the 4a and the negative 4a, the squares, they're still there. So it's just that this now has to deal with the h and the k. And much the same, the other two that open to the right and open to the left. So we start with the y squared, we subtract the k, we subtract the h, same 4a, negative 4a, and now we're just dealing with those values over here. This chart is also in your book. All right, do you feel overloaded with information? Let's take a break and use that information and analyze the graph of this. So I have x squared plus 4x minus 4y equals 0. So let's try to find all those fun things like the vertex and the focus, etc., and then graph it so that we can put this into practice. Now, I prefer my y's to be on one side, so I'm going to do that. So I get 4y equals x squared plus 4x. Now, I could divide everything by 4, but I noticed on the previous slide that there was a 4 involved there, like a 4ax. So I'm going to try to actually get it in that form. Now, I don't have anything here, so I'm going to call back to completing the square. Your favorite thing. Do you remember that we completed it with something where I took the b term and I cut that in half and then I squared it? So that's going to give me 4. So if I add 4 here, that's going to allow me to do this. Is this all coming back to you now? Yes, no, maybe so. So what I'm going to do is I'm going to pull out a 4 here, get my y plus 1, and give me x plus 2 squared. So what I've done next is I've just switched these two to put the x on the left and the y on the right because I'm going to match the equation to one of these on this chart. So it's not going to be the one that sits, or the vertex that sits at 0, 0, because I have an h and a k that are not 0. So the one that matches that is this one. So that's going to tell me that the axis of symmetry is parallel to the y-axis. It's going to open up, so it's going to be something sort of maybe like that. I can find the vertex, the focus, and the directrix. So let's start. So this is going to give me my h, but it's negative. So my h, if I made it positive, is negative 2. And my k right here, if I made that positive, is going to be negative 1. So my vertex is at negative 2 comma negative 1. And my focus is at h, so that's negative 2, and then k plus a. So I have k as negative 1, and then my a is this thing that makes this 4. So 4 times 1 gives me 4. So my focus is at negative 2 comma 0. My directrix is at y equals, so k is negative 1 minus 1. So that's at negative 2, y equals negative 2. And my axis of symmetry is going to be parallel to the y-axis, which means that it's going to go through the x value that is in my vertex and my focus. So my axis of symmetry is going to be x equals negative 2. So let's graph this thing. When graphing, I always start with the vertex if possible, so that's at negative 2, negative 1, label that with a v. Focus is negative 2 comma 0, so that makes sense. It opens up, which means that the focus is going to be in between the lines. And then my axis of symmetry is x equals negative 2, so I'm going to label that with a dotted line just to not confuse myself. And then my directrix is y equals negative 2, which goes here. I'll label that with a D. So in order to make the curve and make it accurate, I need something called the latus rectum. Now, that tells me the length through the focus between the edges of the parabola. So I know that that is 4a, and my a value comes from here. Remember, it's 1. So that's going to be 4 times 1, which is 4. So if I split that in half, that means that 2 spaces from the focus on both sides, perpendicular to the axis of symmetry and parallel to the directrix, those are my 2 points that make up the edges of the lattice rectum. And that helps me graph my parabola. And there you have it. And that's going to do it for this video. Thanks for watching.